The National Electrical Code, specifically NFPA 70, addresses the installation of telecommunication cables. Article 800.133a states that conductors shall not be grouped together in a manner that could result in excessive heating. This provision aims to prevent situations where closely packed cables generate heat that exceeds their insulation's capacity, leading to degradation, potential shorts, and even fire hazards. Several factors contribute to heat generation in cables, including the amount of current flowing through the conductors, the ambient temperature surrounding the cables, the type of insulation used on the cables, and the proximity of other heat-generating sources. When cables are bundled tightly or installed in enclosed conduits without adequate ventilation, the heat they produce can accumulate, raising the overall temperature and increasing the risk of thermal damage. To mitigate this risk, the NEC mandates that cable installations must allow for sufficient airflow and heat dissipation. This can be achieved by using larger conduits that provide more space for cables, employing cable management techniques that separate cables and prevent tight bundling, and ensuring that conduits are not overloaded with too many conductors. Additionally, the NEC specifies the maximum allowable ampacity for different cable types and sizes, taking into account the ambient temperature and the number of current-carrying conductors in a bundle. By adhering to these guidelines, installers can minimize the risk of excessive heating and ensure the safe and reliable operation of telecommunication systems. Article 800.133 states that conductors shall be grouped in such a manner as to prevent the excessive inductance between conductors. Inductance is a property of electrical circuits that opposes changes in current flow. When conductors are placed close together, their magnetic fields can interact, resulting in increased inductance. Excessive inductance can lead to several problems in telecommunications systems, including signal distortion, reduced bandwidth, and increased electromagnetic interference. To prevent excessive inductance, the NEC requires that conductors be grouped in a manner that minimizes the interaction of their magnetic fields. This can be achieved by using twisted pair cables, which have their conductors twisted together to cancel out magnetic fields, separating conductors from each other using physical barriers or spacing, and using shielded cables to contain the magnetic fields. Additionally, the NEC specifies the maximum allowable length for unshielded cables to limit the amount of inductance that can develop. By following these guidelines, installers can minimize the risk of excessive inductance and ensure the integrity of telecommunication signals. Installing multiple conduits stacked together can indeed make it difficult to service the cables within them. If a cable within one of the stacked conduits requires replacement or repair, accessing it can be challenging without potentially disturbing or damaging the other cables in adjacent conduits. This is especially true in tightly packed installations where there is limited space to maneuver tools or extract cables. The congestion created by stacked conduits can also hinder the ability to properly inspect and maintain the cables over time. Technicians may find it difficult to visually assess the condition of the cables or perform necessary tests due to the limited accessibility. Furthermore, the close proximity of the conduits can make it difficult to add new cables or make modifications to the existing system as needs evolve. Therefore, it is important to consider the long-term serviceability of cable installations and avoid configurations that may impede future maintenance or upgrades. Installing multiple conduits stacked together can create a security risk. If one conduit is damaged or compromised, it could potentially provide a path for intruders to gain unauthorized access to the building's telecommunication network or other sensitive systems. For example, if a conduit is located in an accessible area and is not properly secured, an intruder could potentially cut or tamper with the cables inside, disrupting communication services or gaining access to confidential information. Additionally, stacked conduits can make it easier for intruders to trace cable pathways and identify potential vulnerabilities in the system. To mitigate these security risks, it is important to implement appropriate security measures such as using tamper-resistant conduits, securing access points to conduits, and implementing monitoring systems to detect unauthorized access. Furthermore, it is important to consider the physical location of conduits and ensure that they are not easily accessible to unauthorized individuals. There are several alternatives to installing multiple conduits stacked together. Firstly, you can install a larger conduit to accommodate all of the cables. This approach consolidates all the cables into a single pathway, reducing the number of conduits required and simplifying installation and maintenance. When selecting a larger conduit, it is important to ensure that it is sized appropriately to accommodate the total number and size of the cables to be installed. The conduit fill requirements specified in the NEC must be followed to prevent overcrowding and ensure adequate airflow for heat dissipation. Secondly, you can use a conduit system that is designed for multiple conduits. These systems typically consist of a series of interconnected raceways or channels that are designed to accommodate multiple cables or conduits in an organized and efficient manner. Conduit systems can be particularly useful in applications where there are a large number of cables to be run or where space is limited. They provide a flexible and scalable solution for managing cable pathways and can be easily adapted to changing needs. Thirdly, you can run the conduits in different pathways. Instead of stacking the conduits together, they can be routed along separate paths within the building. This approach can improve serviceability by providing easier access to individual cables and can reduce the risk of security breaches by dispersing cable pathways. When running conduits in different pathways, it is important to consider the overall layout of the building and ensure that the conduits are routed in a way that minimizes interference with other systems and provides adequate protection from physical damage.